Hello everyone, welcome to Chapter 4.4 on polyatomic ions. This video will cover information on what a polyatomic ion is, as well as how to write the formulas for polyatomic ions. Polyatomic ions are a group of atoms with an overall charge. They often consist of nonmetals such as phosphorus, sulfur, carbon, nitrogen, and oxygen. And they usually have a -1, 2, or a 3 charge. The only exception is one polyatomic ion that's ammonium, which is NH4+, and it has a positive charge. If you haven't already, you'll want to be sure and pull out your polyatomic ion chart. It's on table 4.7 and should also be uploaded in Blackboard for you as well. Most of your common ions, polyatomic ions, end in ATE. Okay, so this is just a list of some of those. So sulfate, phosphate, nitrate. When there's a related ion that has one less oxygen, so here we have 4 oxygens, it's sulfate. If it has 3, it's sulfite. So it ends in ITE instead of ATE. Some exceptions are cyanide, hydroxide, and ammonium. Okay, now ammonium is an exception in itself because it's the only positively charged ion. Okay, we're not going to worry too much about number 4. It's just basically if you add a hydrogen, then you're reducing the negative charge. And the reason we're not going to worry too much about all of these is the fact that there is good news that I will give you the polyatomic chart on page 138 of your textbook. Okay, this doesn't mean not to look at the chart, not to learn, not to get familiar with these, but I just don't want you to sit there and have to memorize something that you can use, and you can always find a table of these ions. Also, if you have halogens that form 4 polyatomic ions with an oxygen, they usually have a -1 charge. Okay, and here's some names here. So I do want you to go through these, and they are very useful. A lot of polyatomic ions are used, such as sodium chloride is used in processing and bleaching of pulp from wood fibers, and recycled cardboard. But there's many uses for these, and we're going to go through. And now that we know what they are, we're going to learn how to balance the charges when they are in ionic compounds. Okay, so they have a negative charge. All of the polyatomic ions have a negative charge except for ammonium. So we're not going to worry with it too much at the present moment. Okay, so when we are writing formulas for ionic compounds, we are going to use the same rules as we've done with charge balancing. So when we have an ionic compound, remember this is a metal and a nonmetal, but the reason that we keep using and you keep seeing the metal or the cation and anion portion is important here, okay, because now we have a metal, okay, so we have a cation, but we also have a polyatomic ion, which is an anion. So a lot of times you'll see instead of metal, nonmetal, you see cation, anion for this purpose, because now we have a group of atoms that bear a negative charge. Okay, and so we are going to do the same thing here to write the formula. So if we're given the name magnesium nitrate, we want to go to our periodic table and we see that magnesium has a 2+ charge. So you want to get in this habit of writing out the symbol or the name and being sure that you include that ionic charge. Okay, now we have to recognize that we have more than 2 atoms. So far we've just been looking at, 2 atoms. We have a metal and a nonmetal. Well, now we have a group of atoms. So you want to recognize this and be sure that when you go and you can look at your chart, you'll be given this chart, and you see this ion in your chart that it is nitrate. Okay, so we look for nitrate, and it looks like so. Okay. And so the same thing holds true here, is that we have to have a charge balance of 0. Okay, the thing that usually gets students sometimes is they want to try to include this 3 here as the total number of atoms. Okay, this is not the case. Okay, you do not use this 3. Okay, you have 1 polyatomic ion. Okay, you just have 1. You do not have 3. Okay, so you do not use that number there when you're balancing the charge. Okay, so we have 1 negative charge, and we have a positive 2 charge. So these have to equal 0. Okay, once again, you have 1 nitrate. You don't have 3, you have 1. Okay, because you have 1 nitrogen and 3 oxygens with a negative 1 charge, which is altogether 1 nitrate polyatomic ion. Okay, so for these to balance, we have 1 magnesium, we have 2 nitrates, and that would equal 0. And so we would write this out as Mg. We have an understood 1. And anytime you have more than 1 polyatomic ion, you put it in parentheses. Okay? Because if you didn't do this, it would look like this. And that would look very confusing. That would look like a 32. You have 32 oxygens. It's really hard to tell. Okay? And so we would have 2 of our nitrate polyatomic ions. Okay, you can also here, so if you don't want to go through this step, okay, I showed you guys how to swap states on the previous video. So if we have this here, when we're writing formulas, we can use this little trick, if you like it better, where you swap the numbers. So you put a 1 here and a 2 here. So the same thing. We end up with a 1 there, understood 1, and a 2. If you have more than 1 polyatomic ion, you have to put the whole ion in parentheses. Okay, so let's select the formula for each. So we're given the name, and we have to write the formula. Okay, so we're just going to go through, if you want to pause and work these out, and then pick me back up. But if not, we're going to go ahead and get going. Okay, first thing we're going to do, I'm going to use the shortcut way. That's what I was taught in school, so I'm going to use the kind of the swapping of the states for writing formulas. Okay, so the first thing we want to do is we've got aluminum. I'm going to find its symbol is Al on the periodic table, and it has a 3+ charge. Okay, then we want to recognize, first of all, that we have nitrate. Okay, it's not nitride, it's not nitrogen, it's nitrate. So when you see these words, you want to automatically think polyatomic ion. Okay, so you go and you find nitrate, so NO3 minus. So you're going to be given this chart, so you can go there, look on the chart, and it has a -1 charge. Okay. Then all I like to do here is swap my numbers. So I end up with Al1, understood, O3, 3. This 3 comes here. We have to put our polyatomic ion in parentheses, and so our formula should look like number 2. Okay. Now we have a polyatomic ion, and we have a transition metal. So what are we going to do here? Well, we're going to do the same thing. We've got copper, and we know that that Roman numeral is the ionic charge, so it has a 2+ charge, and we have nitrate again. So if we look on our table, we have a -1 charge there. Okay, and so we're going to swap these numbers. So we end up with this. So we have, for every 1 copper, we need 2 nitrate polyatomic ions. Okay. For C and D, we also have transition metals. Okay, we're still dealing with ionic compounds because we have a metal and a non-metal. Okay. So we have iron, just Fe. We have to find this on the periodic table. Your periodic table will also have names under the elements, and it has a 3+ charge. And hydroxide we want to recognize that this is a polyatomic ion. So if we look at our chart, hydroxide has a -1 charge. So if we swap these numbers, basically when we're swapping, all we're doing is we're balancing the charge to equal 0. So we get Fe, OH, 3. Okay, last one, if we have 10, symbol for it is Sn, and it's 4, so it has a +4 charge, and hydroxide has a negative. It's a polyatomic ion with a -1 charge for the whole group of atoms. Okay. If we swap our numbers, we get this here. I actually just saw a mistake that I made. I hope that you caught it, because I just did not see. I have a little trick here. We don't have a 3 here. We need that 3. So hopefully you're paying better attention than I am. But we need, so the answer is here. Okay, it didn't include our polyatomic ion, so our polyatomic ion is NO3, because that's what nitrate is, right? So we have 3 oxygens there, but we have to have a 3 outside. And so I just did not even see that they had forgotten the 3. And so our answer is number 3. So I hope it didn't confuse you there, but I hope this cleared it up, and thank you, and that concludes